Today we're going to graph lines using x and y intercepts. Remember that we said that all we need in order to graph a line is 2 points. So if we can find an x and a y intercept, that will give us 2 points that we can connect to draw our line. So first let's look at how we find those intercepts. We'll start with the equation 2x plus 7y equals 28. Now if we think about it, the x-intercept is where it crosses the x-axis. And on the x-intercept, on the x-axis, the y value is 0. So if we want to find the x-intercept, we put in 0 for y, and we solve for x. And so we get x equals 14. So our x-intercept is 14, 0. If we want to find our y-intercept, we look at the other side of the coin. The y-intercept is where it crosses the x-axis, or crosses the y-axis, where the x-intercept, or the x value is 0. So we're going to put in 0 for x. So we have 7y equals 28, which means that y will equal 4. So 0, 4 is our y-intercept. So that would give us 2 points that we could use to graph our equation. So let's try graphing the line x plus 2y equals 4. So to find our x-intercept, first we plug in 0 for y. If we plug in 0 for y, we get x equals 4. That's our first point. To find our y-intercept, we plug in 0 for x. So we have 2y equals 4, so y equals 2 is our y-intercept. So now we have 2 points, and all we have to do is connect them with an infinite line, and we have our graph. Let's look at example 4 in lesson 4.3. You are helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6 people. This situation can be modeled by 4x plus 6y equals 180. So x represents the number of small tables we get, and 4x is how many people sit at the small tables. Y is the number of large tables, and so 6y is the number of people sitting at the large tables. The first thing they want us to do is find the intercepts of the equation. So our x-intercept is when y equals 0, so we have 4x equals 180, which tells us that x equals 45. So that's one of our intercepts. The y-intercept is when x equals 0, so we have 6y equals 180, so y equals 30. Basically what those intercepts tell us is that if I get over here on the left, if I get 0 large tables, I'm going to need 45 small tables to seat everybody. That's what the x-intercept means in this case. Over here, it's when I get 0 small tables, and so if I only get large tables, I'm going to need 30 large tables to seat everyone. Second part asks me to graph the equation. Now, since I can't rent a negative number of tables, I'm going to only use the positive axis. I'm going to let every other one here represent 5. So, since my x-intercept was 45, I've got to count my way out. To right here. That should be 45. And on the y-axis, my y-intercept was 30, so I've got to count my way up to 30. Right about here. And so I just connect those, and I'm going to use a line segment instead of a line because I can't go into those negative areas. So that's part 2. And just to make sure that we know what our graph means, we're going to label this axis with small tables and large. Now, part 3 asks us to give 4 possibilities for the number of each size table you could rent. So what we're going to look for is exact points that our line crosses, or at least as close to them that we can get. Some of those. We can also use our intercepts. So what we're looking at is my combination of small and large tables. The problem is I can't use this point because the coordinates of that point are 7.5, 25. Now the reason I can't use that point is because that's telling me to get 7.5 small tables, and I can't rent half a table. So that one wouldn't work. However, this one is 15, 20. That one would work. This one's another half. That one would be 30. And 10. And of course I have my intercepts. 45 and 0. 0 and 30. So notice I didn't pick any of these parts down here because they're going to all give me decimal numbers of tables. I pick ones that give me exact number of tables. So it tells me I can get 0 small and 30 large, or 15 small and 20 large, or 30 small and 10 large, or 45 small and 0 large. Let's look at another situation where intercepts might come in handy. A submersible designed to explore the ocean floor is at an elevation of negative 13,000 feet, which is 13,000 feet below the sea level. The submersible ascends to the surface at an average rate of 650 feet per minute. The elevation of the submersible is given by the function E equals 650t minus 13,000, where t is the time since the submersible begins to ascend. Now, we have to use a slightly different situation here, because we're modeling a depth, a negative depth underwater, and it's rising up to 0, and this is a submersible, which means it can't go into the air, so it can't go into a positive elevation. It can only go from a negative elevation to a 0 elevation. So since elevation is my y value, I'm going to need to graph a negative y area with a positive x area, because x is representing time, and time is going to be positive. Y is representing elevation, and elevation is going to be negative. So that tells me I'm looking at my 4th quadrant here, where this is going to be time, this is going to be elevation. Now, they gave me the equation E equals 650t minus 13,000. Now, if we put in 0 for t, that tells us that our E-intercept is negative 13,000. So let's plot that. Let's make each one of these negative 1,000. So let's count down 13 spaces to get to our y-intercept. There we go. Now, if we let E be 0, how long does it take to surface? So take a second and solve this equation and see what we get for our time intercept. And it takes 20 minutes to surface. So we're going to let each of those be 1. We're going to count over to 20. Right about here. So that gives us our line segment, our graph. So they want us to state what the intercepts represent. So here's our y-intercept. That's our starting depth, which is 13,000 feet. Here's our x-intercept, which tells us the time it takes to surface. It takes 20 minutes to surface. we want to identify the domain and the range. The domain, well, it starts at 0, and how long does it take to surface? 20, so our time frame is at 20 minutes. The range, it started at negative 13,000 feet, and what did it end at? 0. So there's our range. Okay, I'd like you to try your own function to graph. I'd like you to graph using a regular coordinate axis, nothing fancy, negative 3x plus 5y equals negative 15. So take a few minutes, find your x and y intercepts, and graph your line. And when you're done, unpause the video and check to see if you got it right. Okay, so our x-intercept occurs when y is 0, which means that negative 3x will equal negative 15, so x equals 5. So we can go ahead and put that on our graph now. Our y-intercept occurs when x is 0, so we'll have 5y equals negative 15, so our y-intercept will be negative 3. Put that on our graph. Now it's just a matter of choosing the appropriate line. Now, since we don't have any domain limitations, we can go on forever in both directions. And that's all it takes. And if you have any questions, feel free to ask, or go back and watch the video again if you need something clarified. Otherwise, you can move on to your homework.